Imagine doing squats with bad technique like this every day. You can do 100 reps and your knees won't thank you. In fact, more than 20% of gym goers have been injured due to incorrect exercise form. The problem is simple. Most people train without supervision, without clear feedback, and without enough strength to control their movements. So I started thinking, what if I could solve it using computer vision? Here you can see my first version, my first attempt at solving this problem. I built a system that could recognize exercises like squats, lunges, and forward bends and give basic feedback on form. It worked, but, well, it wasn't enough. So in this video, I'm gonna show you the final version, the one that actually addresses the problem. In this version, the workout is structured into short blocks with exercises and built-in breaks. It starts with a warm-up, neck rolls and high knees, and then moves into lower body exercises like squats and lunges, and finishes with core stability, bird dog, hip abduction, glute bridge, and plank. After each exercise, the system gives 15 to 30 seconds of rest. It counts reps and guides the user through the entire routine automatically, so they don't have to think about what comes next. The system also provides voice prompts like get ready, start squats, or target 15 reps, so the user doesn't need to constantly look at the screen. For key exercises like squats and lunges, it analyzes technique in real time, and if the form is incorrect, it immediately triggers an alert. At the same time, the interface provides visual feedback, showing what the user is doing wrong and where they are in the routine. It tracks progress, counts reps, and keeps everything on track. At the end, it summarizes the workout, giving a score and showing how many errors occurred in each exercise. And now that you know what my system does, let me briefly explain how it works. So in my first version, I tried to classify the user's movement from scratch, and it could easily confuse squats and lunges because they both involve bent knees. And now, since the user is following a structured routine, they can't accidentally do lunges instead of squats. So I don't need to classify movements. I just need to check if the user is in correct position. So for example, if the current exercise is squats, I'm checking if the user's knee angle is approximately 90 degrees. And if so, they're most likely doing squat, and the system counts it as a correct squat. I know I just said I don't really need classification anymore, but that's not entirely true. I still need a bit of it. So, for example, when evaluating a plank, I need to make sure the person is lying first, because the angles are not that strict. A standing person can receive kind of similar output as the one who's lying or doing a plank, and that's not what I want. So in this case, I check whether the body is more horizontal than vertical by comparing two distances between the shoulders and between the shoulder and the hip. In exercises like hip abduction, I use a slightly different idea. I compare how the shoulders are positioned. If they are spread more horizontally than vertically, then the person is lying in the correct position for the exercise. So as you probably understood, I had to work with angles a lot, and I needed the most efficient way to do so. I had to be careful with the functions I used because, for example, Aten2 was too expensive, and since I was calculating angles on almost every frame, I just couldn't afford that. Instead, I switched to using the dot product. So my function takes 3 points, let's say A, B, and C, each with X and Y coordinates, and it returns the angle at point B in the range from 0 to 180 degrees. But let me just say it, I had some kind of realization here. So here's my full script that counts an angle. It's kind of long, right? But initially, I was rewriting this entire logic inside each exercise-specific function. And it took a lot of space and memory too. So making it a separate function actually made my code a lot more readable and clean, and it made my system perform better overall. So now I can use only one line of code to count any angle I want in any function I want. And let me just say, I did a really dumb mistake here. I'm about to say something obvious. If the angle can be only from 0 to 180, it can be 190. And yet, I spent so much time wondering why my glutes bridge angle that was 190 didn't show any result and didn't trigger any alarm. Well, it was more than my function could calculate. Now that I know the angles and when the user is in the correct position, I can finally count reps. And instead of detecting the whole movement at once, my system tracks just two states, up and down. For example, in a squat, when the knee angle becomes small enough, the system marks the down position. Then, when the user returns to standing, it switches to the up position and counts 1 rep. Without the down state, the system would just keep adding reps while the user stays at the bottom. So this way, once the down state is detected, it won't trigger again until the user comes back up. And actually, the script isn't that hard. It doesn't take a lot of space. And then comes the most important part of my workout system, technique evaluation. And for that, I used angle thresholds. So when a certain angle is below or above a certain threshold, then the technique is most likely incorrect. But it was kind of hard because I had to estimate all the thresholds myself. So I spent a lot of time just working out and doing some random stuff in front of my camera to find them. But the key challenge here was to ensure that camera distance doesn't affect the accuracy. Because if I used short distances, like comparing coordinates directly, the system would rely a lot on how far or close the user is to the camera. So angles turned out to be a pretty great solution. They stayed consistent regardless of the camera distance. This actually works for most exercises, but lunges required a slightly different approach. Because I was calculating a few angles for them, and they're quite sensitive to incorrect form, I had to come up with an idea that would give more accurate results. So here first, similarly to other exercises, the system checks if the user is performing a lunge or no, and if yes, it marks every frame as either good or bad. And then it gets different. Instead of relying on the feedback from a single frame, it counts how many frames were good or bad. And then it calculates the ratio between them. If it's above a certain threshold, then the lunge is considered correct and 1 rep is added. Otherwise, the lunge is incorrect and the system doesn't add any reps. And after that, the system resets and starts tracking the next lunge. And honestly, I think I have to mention that I didn't come up with this idea entirely on my own. It was an advice from a person experienced in computer vision. And I have to say, it made my system a lot better. So, yeah, it's kind of my realization that reaching out and asking for feedback and applying it can actually improve my project. And the last part of my workout system is triggering an alarm. And honestly, it's pretty simple. After the feedback label is generated, the system just looks for the word bad in it. And if it finds it, it turns on the alarm and counts 1 more mistake to the specific exercise so that in the end it could show some kind of a workout score. However, I have to mention that it doesn't turn the alarm on or off immediately. It waits for a fraction of a second because MediaPipe can be really noisy and it can cause a lot of errors. So my system provides some short feedback in real time, but at the end of the workout, it summarizes the overall user's performance. It provides information on how many mistakes the user made in every exercise that was evaluated. It provides the overall score and the percentages of correctness of each exercise. But some exercises work differently. For example, for a plank, I don't really count how many mistakes the user made. I count how many seconds the user held an incorrect position. And for some exercises like neck rolls or hip abduction, I don't evaluate the technique at all because it doesn't really make sense. So that's it for the technical part, and now let me talk a little bit about the design. I redesigned my previous version completely. It wasn't really appealing and it had only 3 tags in the corner of the screen, and it wasn't really practical for a workout either. So I turned it into a complete website using Python's library called Trimlit and a little bit of CSS. So now it has both light and dark versions. So the main part of my website has 3 buttons: Start, Reset, and Stop. And when the workout is active, 1 more button appears: Skip the exercise. Additionally, the screen on the right shows the current process, which exercise is currently active, the target number of reps, how many reps has the user done, and some feedback, for example, bad lunge, too deep. Additionally, it can provide some reference photos of what is expected. Well, that's it, but I actually wanted to talk about challenges and next steps too. I learned a lot while I was developing this, and I'm not talking only about math. It's just overall how the systems are developed, how they're tested, because testing was a really important part of it. I had so many errors that I literally had to do workout every single time something went wrong. And honestly, I'm kind of tired of it. And another huge issues were latency and lags. I'm using Streamlit and I try to analyze almost every single frame, which was a huge mistake. So my system is a little bit laggy. Well, I tried to clean it, but for some reason on squats it still doesn't give a really great performance. The point is, analyzing angles and drawing landmarks takes a lot of memory, so I had to be really careful with that. And going back to angles, I have to say it again, it was challenging working with them. Because as I already said, I needed the most efficient way to calculate them, so I had a lot of attempts to find it. And I'm glad that now it's not that laggy and it counts it right. And finally, media pipe noise is not something I can control, but it still affects my system. Because sometimes my leg can become my arm or it can all collapse. It's unpredictable. And yet, good lighting and clothing can help, but it's still not that great. That's exactly why I added 15 seconds rest, because when you switch the exercise, it can all become really messy. Although I'm really happy with the current version of my project, I know that there's a lot more space to grow. And what I want to do is publishing it and getting real users. I'm aware that I have to do a lot more in order to do that, but I really want to get real feedback and real people testing my workout system. And adding different routines would be also great, for example, for muscle gain or weight loss, because right now I have only one. And I made a widget to enter your body parameters, but it doesn't do anything yet. And finally, I really have to work on accuracy. Although the system can give some sort of feedback to me, it's not really accurate. And I assume that if other people tried my system, it wouldn't be that great either. So that's pretty much it. I told everything about my system and I really hope you enjoyed it. I really suggest subscribing to my channel or going in the description. There's a link to my article about this project. Thank you. Goodbye.